dokey. We're going to continue our learning of how to do linear equations, but now we're going to include fractions with our linear equations. So as you can see here on the board, we've got x over 5 equals 6. The first thing to remember, the main thing to remember, okay, whenever we see a fraction, if we think of that now as the easiest way of doing divide, then we're going to be much better off with our understanding of algebra. So rather than thinking of that as the fraction x over 5, yes it is the fraction x over 5, but if you think of that as x divided by 5, it's going to make your life a lot easier when you're thinking about what to do in order to solve the equation. Okay, so at the moment that means x divided by 5 equals 6. If we think of it like that, it's a good start. To solve it, we use our inverse operations like we learned last lesson. What is the opposite of dividing by 5? Timesing by 5. So if I times that by 5, I'm eliminating the divide by 5. The two cancel each other out. X divided by 5, then times by 5, cancels out the dividing by 5, leaving us just x. Okay? But the golden rule of algebra, as I said last time, is what I do to one side of the equals, I must also do to the other side of the equals. So 6 times 5 is 30. So now we can go back and check whether that's right. If we go back, so we're saying x is 30. If we go back up to the top here and we go, well, 30 divided by 5, does 30 divided by 5 equal 6? Yes, it does. I must have done the question correctly. All right, so the next example, we have x over 4 plus 2 equals 7. So if we think about this one, ultimately we want our answer, just like we were doing last lesson, our last answer to be x equals some number, which means we need, I'll use that one there, we need to get rid of that 2, and we need to get rid of that 4, leaving just x all by itself on the left-hand side of the equals. And we do that with inverse operations. But remember from last lesson, we need to do our inverse operations in a particular order. And I suggested we thought about BEDMAS in reverse. So if we read through this equation now, it reads x divided by 4 plus 2 equals 7. So we have to decide, are we going to eliminate the plus 2 first, or are we going to eliminate the divide by 4 first? Do we all agree that if we use this method, the addition needs to be eliminated before the division?
Yes.
Excellent. So our inverse operations are, we've got to get rid of this positive 2, the opposite of plus 2, minus 2. What we do to one side of the equals, we must also do to the other side. That's our first step. Was there a question why we do it to one side, we do to the other?
Yeah, why do we do it?
Okay, because you can think of your equation like a scales, okay? If you do something to one side, you take 2 away, it's not the same equation anymore. It's 2 less on one side. So it won't balance unless I also take 2 from the other side to even up what I've done. Because that's what the equal signs means. It's like the fulcrum in a scales. Does that make sense? So then I end up with x divided by 4 equals 7 minus 2, which is 5. Notice I'm saying x divided by 4 rather than saying x over 4. I'm really trying to make that point very clear that fractions, in algebra in particular, fractions mean divide. Okay? So now my second step, at the moment it's x divided by 4. What's the opposite of dividing by 4? Timesing by 4 is the correct answer. What I do to one side of my equals, as we were saying before, we've got to keep everything balanced, times 4 to the other side as well. Divide by 4 times by 4, they cancel each other out, leaving us the x, which is what we want. And then 5 times 4 is 20. And unless we've made an accidental mistake, that should be the correct answer. And we can check. Does 20 divided by 4, then adding 2 afterwards, equal 7? 20 divided by 4 is 5. 5 plus 2, yes it does equal 7. We must have got it right. Great stuff. One more example. New page. I can come back to these pages at any time if you need to write them down, so don't worry. Okay, now this question here is a little bit different. And hopefully I'll explain it well because it can be a bit confusing otherwise. We have a fraction, yep. And what that basically means, we've got x plus 11 divided by 4, and that equals minus 2. Same as before, I want my final answer to be x equals some number. So I need to get rid of the 4, and I need to get rid of the 11. Okay? That's a bit messy now, I might just rewrite them. Sorry. But we have to decide which order to do it in. So if I write up the order of operations in reverse again, now please listen to this bit because this is the bit that's a little bit different from the last question. If I was to go through this, you might say to yourself, well, I need to get rid of that plus 11 because it's addition before I get rid of the divide by 4. But there's something about fractions we need to be aware of, okay? If you have items like this, the x plus 11, that are above the same line of the fraction, there is actually, we don't write them in, but there is actually brackets there. The best way of thinking about it is that there's these invisible brackets on the top here. So x plus 11 is in brackets first before we divide it by 4. So if we always remember that, when there's an x plus 11, when there's this couple of items above or below the same single line of a fraction, that there's those invisible brackets. Feel free to draw them in at first if that helps you. Now if we go through this, we can say to ourselves, okay, I've got to worry about that dividing by 4 before I worry about that plus 11 that's in the brackets. Okay? So if we go through that, let's get this out of the way. The first thing we need to worry about is the divide by 4, so I'm going to times both sides by 4. Okay? So the divide by 4 and times by 4 cancel each other out, leaving me x plus 11. And over here, minus 2 times 4 is minus 8. Now I can worry about the adding 11. What's the opposite of adding by 11?
Timing by subtracting.
Subtracting is the correct answer. So I'm going to minus 11 there. I'm going to minus 11 on the other side of the equals. Leaves me x just like I want it. Minus 8 minus 11. So that's minus 8 going back a further 11 away from equals. So it's going to be negative 19. Okay? Again, if we need to, we can check our answers. So if I take the negative 19 and I substitute it, let me just use a different colour here. If I take that negative 19 and I substitute it back into my original equation here, I would have minus 19 or negative 19 plus 11. Negative 19 plus 11 equals? Negative 8, great. Negative 8 divided by 4, does that equal minus 2?
Yes.
Great stuff. All right, thank you very much.